In this video, we're going to go over how to integrate a rational function using partial fraction decomposition. So our first step is to factor the denominators. So 2 over x squared plus x. We can simply just factor out an x there. So I have x times x plus 1 dx. Now what I'm going to do is I'm going to break them into smaller fraction. So I have integral of a over x dx plus integral of b over x plus 1 dx. And I don't know what a and b are, so that's why I'm going to solve for them. Also, the reason why we use partial fraction decomposition to integrate a rational function is because when you decompose them, it makes them into simpler rational functions, so it's easier to integrate. And by the way, partial fraction decomposition is basically the undo of adding a fraction. For example, 1 over 1 plus 1 half, this gives 3 over 2. That's like adding a fraction. But for decomposition, we're pretty much undoing. So it's like 3 over 2. We're breaking them down into 1 over 1 plus 1 over 2. So I'm just going to erase this so I get more space. So we're solving for a and b. So a over x plus b over x plus 1. Now to solve it, what I'm going to do is I'm going to multiply the whole thing by x times x plus 1, the common denominator. So if I multiply to this over here, these and these cancels out. So I just have 2 here and this equals, and now for this, the x's cancels out. So I just have a times x plus 1 plus, and now if I multiply to this, the x plus 1 and x plus 1 cancels out, leaving x, so bx. So from here, you could use a system of equation to solve this, or even better, you can just plug in some x value that'll make one of the term 0. So for example, I'm going to say I'll substitute x equals 0. So this should get rid of the b over here. So I have 2 equals a times 0 plus 1 plus 0, because b times 0 is just 0. So I have 2 here, and this is equal to a times 0 plus 1, which is just 1, and then a times 1 is just a, and then plus 0, but I don't need that. So I know a is equal to 2. So a is equal to 2. What I'm going to do is I'm going to erase a here and then replace that with 2. And now I'm going to solve for b. So to solve for b, I must get rid of a. So I'll replace x with -1, because this will make the a term 0. So I have 2 is equal to a times -1 plus 1 plus b times -1. So here I have 2 is equal to a times -1 plus 1, so this is just 0. A times 0 is just 0, plus b times -1, so this is just minus b. And then I'm going to divide by -1, divide by -1. So I know b is equal to -2. So I'll replace b on top here with -2. Now that we have made them into smaller fractions, we can just integrate them. But before we do that, I'm just going to make them simpler using the property of integrals. So this 2 over x, I can just bring the 2 over it at the front. So it's going to be 2 times integral of 1 over x dx plus, wait, minus, because I can just bring the negative 2 over at the front. So it minus 2 times integral of 1 over x plus 1 dx. Now all you need to know is that the antiderivative of 1 over x dx is simply just ln x with an absolute value plus c. And let's apply that here. The antiderivative of this is just going to be 2 times ln x with an absolute value minus 2, and then for this one it's going to be ln with an absolute value x plus 1 plus c. From here we can just factor out a 2, so I'll factor a 2 out, so I have ln with an absolute value of x minus ln of absolute value of x plus 1 plus c. And then we need to use the property of logs to combine them into one big log. This will be 2 times ln of, because there's a subtraction there, we need to use the quotient rule for the log. So log of a minus log of b, this is simply just log of a over b. So it's going to be x over x plus 1 with that absolute value plus c. This is the antiderivative of this function. Let's try this example. So we have integral of 7x minus 23 all over x squared minus 7x plus 10 dx. So our first step, as always, is to factor the denominator. So the denominator is a quadratic function. So we can factor using the product sum method. So the product is positive 10 and the sum is negative 7. So what two numbers add up to negative 7 but gives you 10 if you multiply it? Well, the two numbers are negative 5 and negative 2, because negative 5 minus 2 will give you negative 7, and negative 5 times negative 2 will give you positive 10. So that works out. So we can rewrite it here. So 7x minus 23 over x minus 5 times x minus 2 dx. Now we'll just break down the fraction. So this is simply just integral of a over x minus 5 dx plus integral of b over x minus 2 dx. So we're once again solving for a and b, like the numerator. So this is equal to a over x minus 5 plus b over x minus 2. And now to get rid of the fractions, I'm going to simply multiply the whole thing by the common denominator. So x minus 5 times x minus 2. So these and these cancels out, leaving us 7x minus 23 equals, and for this one, the x minus 5 and x minus 5 cancels out. So we have a times x minus 2 plus, and then for this, the x minus 2 and x minus 2 cancels, and we're multiplying by this, so b times x minus 5. And now what you have to do is to plug in some x value that'll make a or b 0. So then you can solve for it. So I'll say x is equal to positive 2. So 7 times 2 minus 23 is equal to a times 2 minus 2 plus b times 2 minus 5. So 7 times 2 is 14, and 14 minus 23 is negative 9, which is equal to, okay, so 2 minus 2 is just 0. So a times 0 is just 0. I'm not going to write the 0. And then here it's 2 minus 5, which is negative 3. So negative 3 times b is just negative 3b. And then you'll divide by negative 3, negative 3. So b is equal to positive 3. So I'll replace this b here with positive 3. So now to solve for a, I need to get rid of b. So what I'll do is I'll plug 5 into x. So this will be 7 times 5 minus 23 equals 8 times 5 minus 2 plus b times 5 minus 5. So this is just gone because it's 0. So 7 times 5 is 35 minus 23 equals 8 times, so 5 minus 2 is just 3, and then 35 minus 23 is 12, which equals 3a. And then you'll simply divide by 3, and then so 12 divided by 3 is just 4. So a is equal to 4. So replace a with 4. Now that I have made them into simpler fractions, I'm just going to use the property of integrals to make it simpler. So for this, I can bring the 4 to the front. So this will be 4 times the integral of 1 over x minus 5 dx, plus I'll bring down the 3 here as well. So I have 3 times integral of 1 over x minus 2 dx. So the integral of 1 over x minus 5 is simply 4 times the ln with an absolute value of x minus 5 plus 3 times ln of absolute value of x minus 2 plus the constant of integration. This is the final answer. Try this for yourself. This one, you'll have to break them into 3 parts. For this problem, I have already been given in a factored form, so this is the best case scenario. Since it's already factored, I'm just going to rewrite this again. So 1 over x plus 1 times x plus 2 times x plus 3 is equal to a over x plus 1 plus b over x plus 2 plus c over x plus 3. And now to get rid of the fractions, I'm going to multiply the whole thing by the common denominator, which is x plus 1 times x plus 2 times x plus 3. So this and then this cancels out, which just leaves 1. And for this and this cancels out. So I just have a times x plus 2 times x plus 3 plus, and then for b, the x plus 2 cancels out, which is just b times x plus 1 times x plus 3 plus, for c, the x plus 3 and x plus 3 cancels, so it's c times x plus 1 times x plus 2. So to solve for a, I'm going to replace x with a value that'll make both b and c 0. So like I noticed that here, if I plug in -1, it will also make it 0. So let's do it. X is equal to -1. So I'll replace all the x's with -1. So 1 is equal to a times -1 plus 2 times -1 plus 3 plus b times -1 plus 1. I don't need to write them because it will just get 0 anyways. So plus 0 plus 0. 1 is equal to, so -1 plus 2, so it's just a times 1. So -1 plus 3, this is 2. So I have 2a is equal to 1. So that means a is equal to 1 over 2. So I'll keep that in mind. So a is equal to 1 over 2. Now to solve for b, I need to make a and c 0. So I see that they both have this x plus 2 factor here. So I'm going to replace x with -2. So 1 is equal to, and then this thing is just 0 because -2 plus 2 is 0. So 0 plus b times -2 plus 1 times -2 plus 3 plus 0 because of this here. 1 is equal to, so -2 plus 1, this is just -1. So b times -1 times -2 plus 3, which is just 1. This gives b equals 1. So divide by -1, divide by -1. B is equal to -1. So when x is 2, b is equal to -1. Now to solve for c, I need to make a and b 0. So I notice that they have this x plus 3 and x plus 3 factors. So I'm going to sub x with -3. So 1 is equal to 0 plus 0 plus c times -3 plus 1 times -3 plus 2. 1 is equal to, so -3 plus 1, which is just -2, times -3 plus 2 is just -1. So you just have positive 2c. So 2c is equal to 1. So divide by 2, divide by 2, c is equal to 1/2. So when x is -3, c is 1/2. Now that we know the values for the numerator, we can simply just integrate them in this form. So I'm gonna need more space for that. So the integral of 1/2 of x plus 1 dx plus integral of -1 over x plus 2 dx plus integral of 1/2 of x plus 3 dx. So using the property of integrals, I'm going to take the 1/2 to the front and then the -1 to the front and then the 1/2 to the front. So this is equal to 1/2 of integral of 1 over x plus 1 dx minus the integral of 1 over x plus 2 dx plus 1/2 of integral of 1 over x plus 3 dx, which is 1/2 of ln with an absolute value of x plus 1 minus ln with an absolute value of x plus 2 plus 1/2 of ln of absolute value of x plus 3 plus the constant of integration. This is the final answer for this. Let's try this one. So this one is a bit different because we don't just have a linear factor, we also have like a repeated linear factor. So this will be different. So we're going to have like 3 parts for this. So this will be integral of a over x minus 2 dx plus integral of b over x plus 1 dx, and we're not done. We also have to do integral of c over x plus 1 squared dx. So this is how we're going to break them down. So I'm just going to write this fraction here again. So x plus 1 squared times x minus 2, which is equal to a over x minus 2 plus b over x plus 1. It looked bad, so plus c over x plus 1 squared. Now I'm going to get rid of the fractions by multiplying by the common denominator. So it's x plus 1 squared times x minus 2. So multiplying this and this cancels out. We're left with 5x squared plus 7. So here the x minus 2 and x minus 2 cancels. So we're left with a times x plus 1 squared plus b. So for b, the x plus 1 and one of like the x plus 1 cancels out. So we're left with x plus 1 times x minus 2. And now for this, the x plus 1 squared and x plus 1 squared cancels. We're left with c times x minus 2. Now I'm going to solve for a by replacing x with a number that will make both of these zeros. So like I noticed that I could replace x with 2. So if I replace x with 2, these things will become 0. Because like if I plug in like here 2 here, so 2 minus 2 is just 0, and anything multiplies by 0 is just 0. So let's do this. So 5 times 2 squared plus 7 is equal to a times 2 plus 1 squared plus 0 plus 0. So then 5 times 4 plus 7 equals a times 3 squared. So 5 times 4 is 20 plus 7 is 27, which is equal to, so 3 squared is 9, so 9 times a is just 9a. So I'm going to divide by 9 on both sides, divide by 9, then I get a, which is equal to 3. So when I substitute x with 2, I got a equals 3. Now let's solve for c, because I think I can make this b and a equal to 0. So I'm going to replace x with -1 because it makes a and b 0. So 5 times negative 1 squared plus 7 is equal to 0 plus 0 plus c times negative 1 minus 2, and then 5 times, so negative 1 squared is just positive 1 plus 7 is equal to, so negative 1 minus 2 is negative 3, so I have negative 3c. And then 5 times 1 is just 5 plus 7 is 12, so 12 is equal to, so 12 is equal to negative 3c, and divide by 3 on both sides, negative 3, which is equal to c equals negative 4. So when x is negative 1, c is equal to negative 4. Now to solve for the last variable b, I need to plug in another number. So we'll choose a number that's easy to deal with. So I'll say x equals 0. That's a nice number. So 5 times 0 squared plus 7 equals a times 1 squared, because there's a 0, plus 0 plus wouldn't make anything, plus b times 1 times negative 2 plus c times negative 2. So here 5 times 0 is just 0 plus 7, so you have 7 equals a plus, so 1 times negative 2 is just negative 2, so we have negative 2b, negative 2b times negative 2c. And now we know that a is equal to 3 and c is equal to negative 4, so we can just replace them. So 7 equals a is 3 minus 2b minus 2 times, so c was negative 4, so this is 7 equals 3 minus 2b plus 8. So I have 7 equals 11 minus 2b. I'll subtract 11 on both sides, so 7 minus 11 is negative 4 equals negative 2b divided by 2, negative 2, divided by negative 2. B is equal to positive 2, so when x is 0, b is 2. Now we know the values of our numerator, so we can simply just integrate them. So integral of, so a is 3, so integral of 3 over x minus 2 dx plus integral of 2 over x plus 1 dx plus integral of negative 4 over x plus 1 squared dx. This is equal to, so for the first one, this will be 3 times the integral of 1 over x minus 2 dx plus, and the second one will be 2 times integral of 1 over x plus 1 dx plus, so I'll bring the 4 here. This gives negative 4 times the integral of 1 over x plus 1 squared dx, which gives 3 times ln with an absolute value of x minus 2 plus 2 times ln of absolute value of x plus 1 minus, and now to solve this integral, I'm going to use u substitution. So let u equals x plus 1. So I have integral of 1 over u squared dx. So du is going to be du over dx. So the derivative of x plus 1 is simply just 1. And now I need to solve for dx. So I know that du equals dx. I simply multiply dx on both sides. So du equals dx. So this gives integral of 1 over u squared du. Now I can integrate it. I'm going to integrate it using the inverse power law. So this is simply just integral of u to the power of negative 2 du. So I'm going to add the exponents. So u to the power of negative 2 plus 1 over negative 2 plus 1. This gives u to the power of negative 1 over negative 1. So this gives negative 1 over u. And then earlier I said that u is equal to x plus 1. So this is simply negative 1 over x plus 1. So I have negative 4 here and a negative 1 here. So a negative and negative makes it positive. So I have positive 4. So I have a positive 4 times 1 over x plus 1, which is simply just 4 over x plus 1 plus the constant of integration. So this is the integral of this function. Let's try one last example. So this time I have a quadratic factor. So this one will be a bit different when decomposing. And we can't factor x squared plus 1. So it's unfactorable. So I'm just going to write the fraction here. So x cubed, so 4x plus 3 times x squared plus 1. This will decompose to a over 4x plus 3 plus, this time I'm not just writing b, I will have to write bx plus c, because that's the decomposition for the quadratic, and also because it matches the format. Now our next step, as usual, is to multiply by the common denominator. So 4x plus 3 times x squared plus 1. So this whole thing cancels out, leaving x cubed a times, so this and this cancels, so I have x squared plus 1, x squared plus 1 plus, for this the x squared plus 1 and x squared plus 1 cancels, leaving bx plus c times 4x plus 3. Now that the fractions are gone, I can solve for a first. So to solve for a, I'll make this part 0. So 4x plus 3 is equal to 0. So 4x equals negative 3. So x equals 3 over 4, like negative 3 over 4. So I'm going to plug in x with negative 3 over 4 to make this part 0. So x equals negative 3 over 4. Negative 3 over 4 cubed. A times negative 3 over 4 squared plus 1 plus 0. The other thing gives 0. So 3 cubed is 27, then we put a negative sign, over 4 cubed is 64 equals, so now on a calculator I get 25 over 16a. That means a is equal to negative 27 over 64 divided by 25 over 16. A is negative 27 over 100, which is pretty much negative 0.27. Now I'm going to solve for C by setting x equal to 0. When I set x equal to 0, the b cancels out, and I'm going to replace a with my answer that I just got. So then I'm able to solve for C. So 0 cubed is equal to a times 0 squared plus 1 plus b times 0 plus c times 4 times 0 plus 3. So 0 is equal to a times 1, so it's just a, plus b times 0 is 0, plus c, so 4 times 0 is 0, plus 3, so times 3. So negative a is equal to 3c. C is equal to negative a over 3. So C equals negative of negative 0.27. Negative times negative gives positive. That means C is equal to 0.09, or simply just 9 over 100. 9 over 100. Now I'm going to solve for B. So I will use like a nice value. So x equals 1. So 1 cubed is equal to a times 1 squared plus 1 plus bx. It's supposed to be b times 1. B times 1 plus c times 4 times 1 plus 3. So 1 cubed is simply just 1. And this is just 2a because 1 plus 1 is 2 times a is 2a, plus b times 1 is just simply b, plus c is 0.09 times 7 times 4 plus 3 is 7. 1 is equal to 2a plus 7b plus, so 7 times 0.09 is 0.63. I'm going to subtract 0.63 from both sides. So 1 minus 0.63, that's 0.37. So 0.37 equals 2a plus 7b. So that means a is 0.27. 0.37 So 0.37 equals 2 times A is negative 0.27 because I got it from here, plus 7B. So 7B is equal to 0.37 minus 2 times negative 0.27. So 7B is equal to 91 over 100 divided by 7 divided by 7. So that means B is equal to 13 over 100 or 0.13. Now we know the value of the numerator, so we'll just separate this one here. So integral of A is negative 27 over 100 all over 4x plus 3 dx plus integral of 13 over 100 x plus 9 over 100 over x squared plus 1 dx. At this point, I could factor out a 1 over 100. So I have 1 over 100 times, and I can also bring the 27 to the front, negative 27. So negative 27 times integral of 1 over 4x plus 3 dx plus integral of 13x plus 9 over x squared plus 1 dx. So the integral of 1 over 4x plus 3 dx is simply going to be 1 over 4 times ln with an absolute value of 4x plus 3 plus, and now for this thing I'm going to split this into two integrals. So like integral of 13x over x squared plus 1 dx plus integral of 9 over x squared plus 1 dx. The integral for this, there's a rule for that which you need to remember. So the integral of dx over x squared plus 1 is going to be simply inverse tangent x plus c. This is just a rule that you should remember. But this time we have a 9 here, so we're multiplying by 9. Now for this one here, I'm going to use u substitution. So that means u equals x squared plus 1. That means du, the derivative of u, is going to be, so the derivative of x squared is just 2x, and the derivative of 1 is just 0, so I don't need that. So this is integral of 13x over u dx. So I need to solve for dx. So du over dx is equal to 2x. That means du equals 2x dx. Dx equals du over 2x. So I'm going to replace dx with du over 2x. So du over 2x, and notice that I can just cancel out the x, so I'm going to get rid of this for more space. So now I have integral of 13 over 2u du, and I can just bring the 13 over 2 to the front. So this will be 13 over 2 integral of 1 over u du, and the antiderivative of 1 over u is simply just ln with an absolute value of u. And earlier we said that u is equal to x squared plus 1, so this will be ln of absolute value of x squared plus 1, and then I'll multiply by 13 over 2 because it was at the front. So now I just gotta combine all of the antiderivatives that I got. So our final answer will simply be 13 over 2 ln with an absolute value of x squared plus 1 with an absolute value plus 9 arctan of x plus the constant of integration. And I'm just going to take the c out because it doesn't matter, because if I multiply c with this, it's still c because c is a constant. So 1 over 100 times negative 27 over 4 ln with an absolute value of 4x plus 3 plus 13 over 2 ln with an absolute value of x squared plus 1 plus 9 arctan of x plus the constant of integration. So this is the final answer for this function. Thank you so much for watching this video, and I hope this video helped you how to integrate a rational function using partial fraction decomposition. So thanks again, and I'll see you next video. Bye.